Okay, 1.6 continued. The first thing we're going to look at is vertical shifts with your graphs. We say that the graph of y equals f of x plus c is the graph of y equals f of x shifted c units upward. So if we add a constant to a function, it just moves that entire graph up c number of units. And then by the same example, if we subtract c from a function, the graph of y equals f of x minus c is the graph of y equals f of x shifted down c units. Okay, so the examples you have says to begin by graphing the standard quadratic function f of x equals x squared, and then use a transformation to graph the given function. Okay, so in the first graph, I'm going to graph f of x is equal to x squared. Okay, that's my parent graph we talked about on the earlier handout, which is just a parabola from 0, 0. Now, you don't have to have these exact. I just want you to sketch. Okay, it's a parabola. That's my original function. So if I want to graph this equation here, which is a transformation of this one, it's g of x equals x squared plus 2. I've just added 2, the constant 2, to my original function. So that means it's going to shift my graph 2 units upward. So instead of being at 0, 0, my transformation would be moved up 2 units to 0, 2, and then we would draw the parabola. Now on paper, like I said, we're just sketching these out. On my math lab, whenever you get your point here for your vertex of your parabola, you will need to actually plug in a value for x in order to get your second point. So if I wanted to know exactly where another point should be, I might plug in a 2. You know, if I plug in a 2 into this function, g at 2 would equal 2 squared plus 2, so 4 plus 2, which is 6. So I would know my exact point for this should be 2, 6, so a little bit bigger than what I had, but that's for your homework on my math lab. Okay, they may want the exact points. Alright, number 2, it says begin by graphing the standard square root function f of x equals the square root of x. So we should know what that looks like. Okay, if you study those graphs, that it's a graph like this. Okay, just a half curve. If I want to graph the transformation, g of x equals the square root of x minus 2. I've just subtracted 2 from the function. So that means instead of being at 0, 0, it's going to be at 0, 2 would be my starting point, and then I would have the same shape of curve. Everything would just be shifted down 2 units. Okay, number 3. You're graphing the standard absolute value function. F of x equals the absolute value of x. So we know that looks like this. The transformation is the absolute value of x minus 3. So I'm subtracting 3 from the function. So instead of I usually just start with my vertex. Instead of it being 0, 0, it's going to be shifted down 3, which is here, and then would have the same shape. Okay, number 4, we're graphing the standard function f of x equals x cubed. So that's our cube function, which looks kind of like this. If we draw a curve, okay, we just want to get the basic shape. It doesn't have to be exact. We are subtracting 2 from it, so that means it's just going to be moved down 2 units. So instead of being at 0, 0, where my curve is, it's going to be at 0, negative 2. So I would have the graph shifted down 2 units. Okay. Okay, and then number 5 is not one of our specific graphs. It just says to graph, or you're given the graph of a function f. Okay, this is y equals f of x. Graph the transformation. So it's just that g of x equals f of x plus 1. So it's this function plus 1, which means it's just been moved up 1 unit. Now I can look and see that this point is negative 4, 4. This point is 4, 4. And then I have a 0, 0. So I know that's going to be up 1. And instead of being at 4, 4, it would be moved up 1 unit. So it would be at 4, 5. Okay, again, just showing that you understand how the vertical shift looks in your equation, and then how to actually change that on your graph.